Hello guys and welcome back to LeetLogics. This is the design graph with the shortest path calculator. It is a LeetCode hard and the number for this is 2642. But I am sure that it will not be a hard question if you watch the video till the end. So in this question, uh, the problem involves implementing of a class to represent a directed weighted graph, and we also have to perform operations such as initializing the graph, adding edges to the graph, finding the shortest path between the nodes of the graph, and these operations. And so we are given with a directed weighted graph. As I told you, we have to implement the constructor, a function add edge. We have to add this edge to the graph, and we also have to tell the shortest path between the node 1 and node 2. So we need to implement this. So to find the shortest path, we can use something called Floyd-Warshall algorithm. Like, it is a very famous algorithm. If you want, I can create a separate video on the Floyd-Warshall algorithm. Otherwise, you can study it from any of the website like Geek for Geeks or any other. You can study the algorithm and get to know how we have used it here. If you want, I can make a video. Please do write in the comment section if you want a video on Floyd-Warshall. And so first of all, in this question, let's see an example. So we have taken an example with the number of nodes given as 4 and edges equal to 2, 4, 5, 1, 0, 1, 2, 1, 2, 1 and 3, 0, 3 as given in the sample example 1. So, and in this we have to add a new edge 1, 3, 4, and we have shortest path queries 3 to 2, 0 to 3, and after adding 1, 3, 4 we have 0 to 3 also again. So in this we have something known as a distance matrix. So we'll create a distance matrix initially, and we can like, first of all, the distance of 0 to 0 is actually 0 and rest of the infinity. Then one by one we are going to add the edges between the nodes, and then on that basis we see that what is our distance matrix. So after initializing with all the edges, our distance matrix becomes 0, infinity, infinity and 3. And we also, now this was before adding of the new edge, then we have to add a new edge 1, 3, 4. So after adding this 1, 3, 4, the distance matrix before updation was 0, infinity, infinity, 3, and after updation also it is 0, infinity, infinity, 3, but this 3 comes from the new edge. So then we will have shortest path query 3 to 2 is 6, 0 to 3 is -1, and 0 to 3 after 1, 3, 4 is also 6, because nothing has changed actually after the addition of the new edge. So you can see the answer was also there: null, 6, -1, null, nothing will be printed, and 6. So this is the, I think, correct solution. So let's come to the code. So in this part we have the initializing. We initialize the graph with the number of nodes and the given edges by creating a adjacency matrix to represent the graph. Distance is the adjacency matrix, and we set the initial distances based on the given edges, and we apply the Floyd-Warshall algorithm to compute the shortest paths. And then we have a adding edges function. This is pretty simple, like we have to only add the new edge to the graph both ways, and also like we have to calculate the shortest path of the edges what we have added. And then in the shortest path we simply return, like, since we have already calculated here using Floyd-Warshall algorithm here, So we need not to calculate it again here, we just simply return. If it is equal to maximum value, we return -1, not reachable, otherwise we return the distance what we have. So this was my code. You can take a screenshot if you want, one by one. So this is the first part and this is the second part. This is the Java code. If you want the C++, Python and the JavaScript code, you can check out my LeetCode solution. It is with this name. You can see this one. Uh, it has all the Java code, C++ code, Python code, JavaScript code, and do remember to upvote, like this video, share this video with your friends, subscribe to the channel. If I talk about the kind of time complexity of the codes, so the time complexity is actually n cube and the space complexity is n square for the initialization section. Like for this part, the time complexity is n cube and space complexity is n square. As n square comes from here, space complexity, and the n cube time complexity comes from here. You can see n, and this will make the time complexity and the space complexity for the entire solution, because the time complexity for this part is n square and space complexity is O of 1, and for this it is O of 1 both space and time. So the time complexity is n cube and the space complexity is n square, which comes from this section. So this was my solution, mainly based on Floyd-Warshall algorithm, and I hope you like the video. uh, Please do like the video, subscribe to the channel if you are new to the channel. Thank you for watching the video. Have a nice day.